Hello, everyone. First of all, I would like to thank Ian. I think he explained LDG and NGCS quite perfectly. So a lot of my work has already been completed, but I will try to go a little bit about the project that we have been carrying out for National Highway. So I will go into 5, but I will touch on LDG and NGCS a little bit faster because Ian has already mentioned these. I will touch on the international experiences, how LDG and NGCS are different, and the proposed trial that we're going to carry out. So we are doing this work as part of the concrete road framework for the National Highway. So as for LDG, as Ian has already mentioned, it's a pavement restoration technique that we use it for either asphalt or concrete. We are focusing on our research on concrete. So we have a grinding head and we have a blade and we have some spacers, and they end up stacking them together into like a drum or a shaft or whatever they call it, and then they end up rotating this into the flow of the traffic at a constant speed and pressure. We have MCHW 1092, which provides requirement for LDG in the UK, and it was first used in 1965 in the US. So how does it work? It provides what we call a positive texture, and as you can see it here, I tried to look into available research how we can define positive texture and negative texture. The only definition I could find was from Nick Tom from the University of Nottingham, which unfortunately he's not here today, and I have not memorized his definition. But what you can imagine, a flat surface, and then add some peaks on it, and you get a positive texture. If you have a flat surface and you have some valley in it, you end up with a negative texture. What LDG does, it does a positive texture, which have good skid resistance, but however, it have some detrimental from acoustic point of view. The LDG ends up generating what we call fins that are breaking down. As you can see here, we have some breaking down in the fins. This causes some increase in noise reduction. Then we move to next generation surface or concrete surface, and one particular aspect that we found difficult at the beginning of this research is the terminology. First of all, you can see in Australia they call it low noise diamond grinding. You will find in Germany they call it they're developing standard A, which is acoustic grinding. So you'll find different terminology. We ended up going with next generation concrete surface, which is the one used in the US. It has been developed in the US in 2007 and has been widely implemented in the US, Australia, and South Korea, but it has also been tried in Germany, Canada, and Belgium. We've seen from field trial that there are some improvement in noise reduction and in skid resistance. Currently, MCHW does not include a clause for NGCS, and we hope by the end of this project we will be able to develop one for them. It has been recently trialed on Strategic Road Network, as Ian has mentioned, so we appointed a technology readiness level of 7. As we can see, we have the same blades, but we have an additional blade here that causes the grooving. As Anna has mentioned, this is how they do it probably in Germany, where they work on one pass and they are able to grind it immediately. However, from international experiences again, it has been recommended that this is being carried out in 2 phases or in 2 passes. So we first do the grinding and then we do the grooving. This generates a negative texture, which as we discussed in here, so you have the valleys. This causes lower noise, so additional noise reduction, but there are little information on their long-term performance. The equipment that we use for NGCS is identical to the one of LDG, but we have different blade configuration. Again, this has caused a little bit of issues. So in Germany, they have something they call standard S+, which is their standard S, which is the grinding, but with some grooves. However, we will see that the texture, the blade configuration play a major role in how next generation concrete surfaces work. So again another pictures showing LDG, NGCS grinding step, and then NGS grooving step. The LDG removes deep defect, which will cause, if your surface is not really even, you can do LDG to remove any unevenness, and this will help you save your blades so they don't wear too much faster. Then you have the grinding step, which will minimize positive texture. And then we have the grooving step, which will create your negative texture. As you said, we can combine these into one pass. However, this could promote an even wear of the blades. Then we started looking into international experiences, and what we were trying to optimize was to see if the configuration will play a role in how noise and skid resistance mainly work. We look at different attributes as well, but we were focusing more here on noise and skid resistance. So it was first used in the US, and they have currently, based on the IGGA, they have this type of blade configuration. So we have a 3.2 millimeter blade thick, they have some spacer, and we can see it's like less than 1 millimeter. And then we have grooving, which are grooving with a smaller blade than the one they're grinding. Overall, we can see a 2 decibel reduction compared to LDG, and we have some consistency in friction over 4 years. We also look at the Canadian standard, which are using the same blade for grinding and grooving, but they are using a finer spacer between the grind. So it's a finer grinding. Again, grooving space has been set between 12.7 and 15.8. We look also at the Australian, which I couldn't really find the blade configuration, but they usually follow the IGGA. Again, we are seeing promising noise reduction here as well. In the Canadian experiences, we were able to see some deterioration in skid resistance, but it stabilized after 2 years. Then we look at the German one, and they have 2 experiences, one in 2014, one to 2015. And we are also seeing different blade being used. Here, grooving is being carried out with a blade that is thicker, similar as here. What we are seeing here, however, is that they are going for a spacer that is 1.8, 1.5, so it's above the 1 millimeter. And we are showing that, yes, you still get some noise reduction, but it's below expectation. Then we also look at South Korea. So South Korea have a very high use of NGCS. They use it mainly in tunnel, and they use it in new build. They were able to report a 7.5 decibel reduction, but I was unable to exactly identify to what they are comparing it with. So there was not a lot of data, but it's very interesting to see 7.5 decibel. Again, it's a much fine grinding, and we can see also good skid resistance. Recently, it's also being carried out in in Belgium, and they're also using a slightly thicker spacer. We were able to see, like, yes, there were some noise reduction, but they're finding what we were more interested in is to see that finer grinding profile resulted in greater noise reduction. So now we had to compare LDG to NGCS. So we know NGCS will provide us the 2 decibel as a minimum of noise reduction compared to LDG. But however, the construction of NGCS will be typically 50% to 100% higher than LDG. And this is attributed to 2 main causes. One, you have a longer installation time because you have to carry it into 2 passes, and you have an increased wear of the blade, which are very expensive and will account for most of your cost. However, we cannot only look at the construction cost to make a decision. So we looked at the whole life cost, and unfortunately, there are limited information on this regard. What we can say for sure is that when you have an LDG that has deteriorated, you can resurface it again with another LDG. When it comes to NGCS, we've seen from American experience that once you lose your grinding profile, it's really difficult to get it back. They have developed something called NGCS Lite, but unfortunately it has not been very successful. So it's something to consider. However, what we can say is that the macro texture, which are the grooves, has not been reported to deteriorate in 10 to 15 years. So additional research on how we can get the microtexture on the NGCS profile could still be feasible. And we've seen also from the US, which has the longest experience with NGCS, that we can still carry out some noise reduction and skid resistance for over 10 years. So it's very promising in terms of its usability. Again, the main benefit of NGCS would be the noise reduction. So how do you consider the benefit of getting the 2 decibel compared to that additional cost? So it's something to consider. How do you quantify in money the benefit of the 2 decibel improvement? So what we wanted to do now is to carry out some trials to try to identify the best or the most optimum profile that can help us reduce cost, but at the same time maintain some benefit in noise reduction. So we started from a very basic profile which uses the same blade with a very fine spacer and some spacing widths. Then we tried to move and change one by one the parameter to see their effect. So profile 2 is using a finer grinding blade, while profile 3 is using a thicker grinding spacer. And the argument here is that a finer grinding spacer and a finer grinding blade will result in much noise reduction, in much higher noise reduction. However, it will be attributed with a higher cost. And of course, you might see like there are very minimum changes, but we've seen from international experiences that this will affect greatly on cost and noise reduction. We've also looked at the current IGGA spec, which uses a finer grooving blade, 2.4, and this was the original IGGA, and they have changed it recently to here, to this one, because of lateral stability. So still, again, we need to check how this affects on our road and what the benefit that we can get from it. Finally, we look at the grooving spacer. So the grooving spacer, we don't believe it actually helped in noise reduction. So this is based on conversation with IGGA, with many people who have worked with noise reduction, but it helps in hydroplaning. So we need it for skid in wet condition. And when we were able to reduce it from 12.7 to 15.8, you have a big saving in your blade wearing. So there might be a lot of benefit in testing this one as well. We'll also be carrying out different tests, and hopefully we'll be able to do the trial in 2023. So 3D laser texture depths, we're looking at OBSI, CPX. Originally, we were going for CPX because it's the one recommended by MCHW 1092. But however, CPX is not available in the UK, and I think BritPav have been working on OBSI, and we believe OBSI could also be a potential alternative. We're also looking at surface rider quality, visual condition, texture, skidding resistance, and ELPV. Hopefully, next year we will have some data to show how these have improved, and we can also recommend some requirement. The third phase will be to add an MCHW standard, hopefully, and we will see how that goes. And that's probably everything for my presentation. Thank you very much.
Emma, thank you.